Solve the equation the square root of x plus 23 is equal to x plus 1. This is called a radical equation because the variable x is underneath of a radical symbol. So the strategy is to isolate the radical expression, which is already done, and then raise both sides of the equation to the power that is equal to the index of the radical. In this case, our radical is a square root, and so we will square both sides to begin. On the left-hand side, the squaring undoes the square root, leaving us with the radicand, which is x plus 73. On the right-hand side, we want to be careful. The square of x plus 1 means to multiply x plus 1 by itself. We go ahead and perform the multiplication on the right-hand side. X plus 73 is equal to, use the foiling method if you like, multiply the two first terms to get x squared, multiply the two outer terms to get x, multiply the two inner terms to get x, and multiply the two last terms to get 1. So x plus 73 is equal to x squared plus 2x plus 1. Now the result of squaring both sides is that we end up with a quadratic equation. We have an x squared term, we have a couple of x terms, and we have some constant terms. So our strategy at this point is to obtain 0 on one side of the equation. So let's go ahead and take away x from both sides, and also take away 73 from both sides. That way we obtain 0 on the left-hand side, and on the right-hand side we have x squared plus x minus 72. Now that we have 0 on one side, we factor the right side, which means that we want to write the polynomial as a product of two factors. So we're in essence doing foiling in reverse. We want to think of the two first terms that multiply together to give us x squared. That would be x and x. X times x gives us x squared. And then we want to think of the factors of negative 72 that add up to 1. Well, 9 times negative 8 is negative 72, and 9 plus negative 8 is 1. So one of our factors will be x plus 9, and the other factor will be x minus 8. Now that we have a product that is equal to 0, we can apply the zero factor principle. The only way that a product can be 0 is if one of the factors is 0. So either x plus 9 is 0, or x minus 8 is 0. Subtracting 9 from both sides gives us x is equal to negative 9. Or adding 8 to both sides of this second equation gives us x is equal to 8. Now a lot of students will stop at this point and they end up getting the problem wrong. We haven't done anything incorrect, but when we squared both sides, we may have introduced extraneous solutions, apparent solutions that don't actually satisfy the original equation. So it is very, very, very important that we check our result. So let's go ahead and check. And we'll start off with x is equal to negative 9. So we go to our original equation and we substitute negative 9 for each x. So we get the square root of negative 9 plus 73 is equal to negative 9 plus 1. On the left-hand side, negative 9 plus 73 is equal to 64. And the radical symbol indicates the positive square root of 64. The positive square root of 64 is 8. On the right-hand side, we get negative 9 plus 1, which is negative 8. Well, 8 and negative 8 are not equal to each other, so the result of our check is a false statement. That tells us that x equals 9 is an extraneous solution. It does not satisfy the original equation. So negative 9 is not a solution. So we'll cross off the negative 9. Negative 9 is not a solution. It does not check. All right, well, what about x is equal to 8? And when we check x equals 8, we get the square root of 8 plus 73 is equal to 8 plus 1. 8 plus 73 is equal to 81. And 8 plus 1 is equal to 9. The positive square root of 81 is 9. And so we end up with 9 equals 9, which is a true statement. So that tells us that 8 is a solution. We want to keep x equals 8. X equals 8 is a solution. So the solution to the equation is simply x is equal to the number 8. So x equals 8 is a solution, but x equals negative 9 is not.